Do you dream of the day when you can leave the rat race behind? Move to the country and stop paying an electric bill? The Chases did it, and so can you. They will show you how to reduce your utility bill by 50 to 100%. You can enjoy a normal lifestyle without that annoying power bill. You will see you don't have to camp out the rest of your life to do it. Every day the sun sends 400 million times more energy to the earth than we can use. All you need to do is harvest just a bit of it. The best part is that the energy from the sun is free. And no matter how much they would like to, the power companies can't put their electric meter between the sun and you.
Hello. Welcome to our solar electric home tour. I'm George Chase. This is my wife Joyce. We designed and built the 2,000 square foot energy efficient home you see behind us. When we started doing research back in 1981 on this project, there were no homes like ours where we could go and learn about what solar power could and could not do. That is why every October since 1993, we have opened our home to over 3,500 guests in conjunction with the National Tour of Solar Homes, sponsored by the American Solar Energy Society. We have been involved with solar for over 20 years and have gone from being curious to designing and living in the solar home to designing solar systems for others. Back then, system components weren't always available, and the ones that weren't always reliable. Today, however, components are high-tech and off the shelf. Reliability is not an issue. Our plan today is to give you the same tour we give to groups as large as 50. Most of the energy tips you learn today can be utilized in your own home, so you can start saving money on your utility bill right away.
When we bought our property in 1981, the power lines were about a mile away, so we called our local power company to have them bring power to our site. They told us it was going to cost about $15,000. We looked at it this way. We pay them $15,000 up front, and they promised to send us a bill each and every month for the rest of our lives with no guarantees to keep the rate steady. We didn't think this was such a good deal, so we decided to look at alternative sources of power. We looked at wind, hydro, and solar. For this particular site, solar power proved to be the best. There are many site advantages and disadvantages. What you need to do is try to utilize everything you can to minimize your cost for power. That way, the cost for the equipment will stay much lower. There are many advantages to living on solar power. Reliability is right at the top of the list. We have never had a power failure in all these years. And aside from the fact that we get no power bill every month, the environment gets a huge benefit from us not using commercial power. 83% of all the emissions reported to the Florida Department of Environmental Protection come from power plants.
That's right. And if you speak to experts from the power industry, they will tell you that solar power is not cost-effective or easy or reliable. We're here to show you that solar power is indeed all of those and more. Let's start by showing you the PV array. PV stands for photovoltaic. Our array has 14 47-watt modules, 4 80-watt modules, and one 30-watt module. Together, they produce about 1,000 watts. We can count on 6 good hours of sun every day here in Florida. Therefore, we produce 6 kilowatt hours each and every day. Now, 6 kilowatt hours would not begin to run most homes. The average home connected to the grid uses 50 to 60 kilowatt hours every day. However, since we use about 3 and produce about 6, we don't have any problems. We will show you how to do the same with your electric bill.
Earlier, I mentioned site-specific conditions, and here is a good example. This house is 72 feet long. In Florida, when building a house, you would try not to position it with the long side facing west because the afternoon heat gain is tremendous. Yet on this particular site it works. First we determined the prevailing breeze. For this site it is east and west. By placing the long side of the house facing east and west, we are able to capture as much of that breeze as possible and channel it inside. And since we didn't cut down all of these trees on the west side, they provide shade to keep the afternoon sun from hitting the house.
We also built long overhangs, 30 inches, which create shade for the walls and protects them from the rain. Most homes built today have almost no overhang, which makes it easier to meet the building code for hurricanes. But it pays to add extra tie-downs and utilize the long overhangs, which then allows you to install continuous soffit venting and ridge vents. Both help keep the attic much cooler. In existing homes, you can add radiant barriers under the rafters to reduce heat gain. It works by reflecting heat back towards the roof. The heat can then exit the ridge vent. In the process, this creates a natural flow of bringing in cooler air from the soffits, helping to keep the attic much cooler.
This is our utility shed, and since we get high water on occasions, it's designed a little different than most. We have chains from the back corners that lead to trees. Then we have another chain that connects the front of the shed to a third tree. Under the shed is styrofoam about 2 feet thick that will float over 5,000 pounds. So when the water comes up, the shed floats up, and then it all comes back down in the same place, and nothing gets wet. While we're here, please notice our solar clothes dryer. It's the most energy efficient dryer on the market.
Back in 1981, when we decided to go solar power, we went out and bought a state-of-the-art solar pump. It used 12 volts DC at 29 amps. Gave us 2 gallons a minute at 25 psi. Now that's a lot of power and not much water. Well, today, this is state-of-the-art. This is a SureFlow model 2088, 12 volt DC. Uses 1/5 the power of the older pumps. Instead of 2 gallons a minute, it gives us 4 gallons a minute. And instead of 25 psi, it gives us 45 psi. Now you can tell that state-of-the-art solar is improving. Every year things are getting better and better. Now while we're talking about pumps, I'd like to mention the DC motors are inherently more efficient than AC motors. So if you can find a DC motor to do the job you need to do, it will do it using far less power. And that's the name of the game. If you live in the woods, you have to be prepared to fight a fire on your own. This is a 5 horsepower Briggs & Stratton gasoline engine. It runs a pump that takes water from the creek so that we can use a fire hose and fight a fire ourselves. Now it puts 75 psi at about 160 gallons a minute. That is minimal fire protection. However, if you're a long ways away from a fire company, you've got to be able to do it yourself. Here we have our backup charging system. When you live on solar power, it's good to have a way to charge the batteries in case of stormy weather. Now you could go out and spend a few $1,000s on a big fancy generator, but remember, generators are high maintenance items, spew a lot of pollution, and suck up fuel. This entire unit didn't cost $100. This is an old 60 amp alternator, a 2-to-1 gearbox, and a PTO shaft. It takes about 3 minutes to hook this up to my diesel tractor, which will run this charger for 15 cents an hour. I don't think you can buy a generator that will run for 15 cents an hour. I'd like to talk about water heaters. Ours holds 10 gallons and uses propane. It came out of a wrecked RV over 20 years ago. People ask us why we don't have a solar water heater. That's because you must have at least 4 or 5 people in your household for a solar water heater to be cost effective. If you don't have 4 people, you should be heating your water with propane or natural gas. Most of you have electric water heaters, and that is the least efficient way to heat water. As soon as it springs a leak, replace it with gas. Now I'd like to invite you inside our home for more energy-saving tips. Joyce wants to start in her favorite room, the kitchen. Come on in.
The first thing people notice in our kitchen is that this refrigerator doesn't look anything like theirs. This one is made in California by Sunfrost, and this is our biggest energy consumer in the entire house. It uses between 500 and 600 watts a day, whereas your refrigerator uses between 5,000 and 6,000 watts every day. This sunfrost is more efficient because of its shape, the thickness of the walls, and the part that produces heat is up on top. Heat rises, so it only makes sense to put that up where the heat will go up and away from the box. Also, it's not self-defrosting. Your refrigerator takes more energy to keep it defrosted than it does to keep it cold. We have to defrost this 2 times a year, and it only takes about 20 minutes each time. There are about 100 million homes in the United States, and if every one of them had an energy-efficient refrigerator like this, we could eliminate the need for 18 large nuclear power plants.
As you probably expected, we use a gas stove. Gas is the most efficient way to heat. Electric stoves are very inefficient. Ours uses the pilot light system, which is the most efficient of all. A state-of-the-art gas range today must be plugged into 110 in order to work. It will use more electricity to bake a potato than if you baked it in a microwave oven. Now, why should a gas stove use any electricity to bake a potato? Well, the manufacturers have replaced the little efficient pilot light, which is down the bottom of this stove, with a glow plug, which uses about 600 watts to glow red hot the entire time the oven is on. Now, we think that was a calculated move to sell more electricity. The electronic ignition in the top of a state-of-the-art stove would not be a problem because it only uses the electric for just a fraction of a second to start the burner. Since it's hot here in Southwest Florida most of the time, so we have turned off our pilot lights and we use this little striker to light the burners. We have a standard hood over our stove. However, we replaced the light from an automobile. It goes in a little adapter like this, which allows you to make any 110 lamp into a 12-volt lamp. You just need to plug it into a 12-volt source. We've also replaced the 110 fan that came with the hood with a fan that uses 12 volts. It uses less energy and puts out more air than the 110 fan that came with the hood.
For our 12-volt circuits, we use these mechanical switches that make a snapping noise. With low voltage, you can't use the silent mercury ones because they could arc. You can go out and spend a lot of money on special DC rated switches, or you could look for this older type and save yourself a lot of money.
We have 2 completely separate electrical systems in our home, a 110 and a 12-volt DC. In your home, the outlet we have on the right would be used for your 110. This one on the left would be used for 220. In our home, we use the one on the right for 12 volts and the other for 110. The code states that for every voltage you have, you must have a differently configured outlet. That is so that you don't accidentally plug the wrong thing into the wrong place. However, if you come to our home and you have an electric razor, for example, you could plug it into our outlet on the right, but the 12 volts that's there wouldn't begin to power it. So we made these little adapters. You plug your razor or hair dryer or whatever into the adapter, and that gets you into our 110 system. This is a standard 110 mixer, which we use all standard 110 appliances in our kitchen. Now, I could cut the plug off this and put one of our plugs on it to get right directly into my 110, but then that would void the warranty. Incandescent light bulbs. If you invent something that is 95% efficient, you did a good job. Well, incandescent light bulbs are 95% efficient at producing heat. Only 5% of the energy being consumed here produces light. So, if you were trying to design a heater, you did a good job. If you were trying to design a light bulb, you didn't do so well. To top it all off, only 35% of the energy being produced by the power companies gets to be used in the home. The other 65% is lost in transmission and inefficiency. And who do you think pays for that? Right, you do.
Everyone should switch to compact fluorescents. These are both made by Philips. You should use these in all of your light fixtures except in closets or places where the light is on for only a minute or so. These bulbs cost about $10 to $15 depending on the wattage. Why spend that much when an incandescent bulb costs so much less? Compacts use 75% less power, produce almost no heat. Each one saves 1 ton of carbon dioxide and 20 pounds of sulfur dioxide from going into the air at the power plant. And each one will save you over $35 to $45 in electricity costs over its long lifetime. Here in our great room, these 14-foot high ceilings help to keep the heat up and away from the living space. As heat rises, it can go out that window, which opens at the top. The rising heat also pulls cooler air in from the lower windows. This window is really too high to operate by hand. And since we're so energy conscious, we didn't want to install an electric motor just to operate it. So here's what we did. This is really high tech. This is just a few strings of monofilament fishing line with some weights on the end. And all we have to do is simply pull it and the window will close. Now maybe you're thinking, how can I possibly open it? I can't push it with this string. No, but if you designed a balance system correctly, you can just shift the weights on the string and it will open, and no expensive motor is needed.
You'll notice we have lots of door and window openings. That's to allow us to channel as much of the breeze from outside inside. We all know how a funnel works. Well, we can create a big funnel right here in the house. If we open all the doors and windows on that side and close most of them on this side, except for where we might be sitting, that increases the speed of the breeze in this portion of the house in order to get out this smaller opening. This stove is a major source of heat for the house. We have some space heaters in the bedrooms, but we seldom use them. This is not your grandfather's wood stove. It has a catalytic combustor in it. The catalytic combustor takes the gases that normally went up the chimney and cause pollution and reburns them, in the process eliminating the pollution and also creating much more heat from the same amount of wood.
This is our entertainment center. Up here we have our stereo. This is actually a car radio that plays both tapes or CDs, and it uses a fraction of the power of a 110 system and sounds just as good. You could spend a lot more money and not get any better sound than we have here for an investment of about $300. This is a 12-volt color TV that has a remote. We put a switch on the power line to make sure that when it's off, it's really off. Now the controls for your TV, VCR, and stereo all consume power 24 hours a day, 7 days a week, even when you're not watching them. This is called phantom loads, and they really add up. The average home has a lot of phantom loads. For example, a 19-inch television, a microwave oven, and a VCR, all across America, add up to 22.5 million kilowatt hours per day. That means you pay about $2.25 million to the power company for doing absolutely nothing. So what you need to do is plug your TV, your VCR, your stereo into one of these power strips so that you can completely turn them off, and that will save you a lot of money and is much better for the environment. Most people would use over a 100-watt light bulb to read by. I use this task lamp. By putting a small 5-watt quartz bulb near my task, I get just as much light as I would from a much larger bulb. That's a 95% savings. Of course, not everything is that efficient. I use a standard 110 automatic washer. It takes 600 watts to wash and over 1,200 watts for the spin cycle. So if you're shopping for a new washer, be sure that the water is pumped out first before going into the spin cycle. Water weighs over 8 pounds a gallon, and if it isn't pumped out first, it takes more energy to take all that water and all those clothes and put it into the spin cycle. Front-loading washers use even less water and power. Also, you can install low-flow shower heads, faucet aerators in your kitchen and your bathrooms to save water. If you don't have a low-flow toilet, use a toilet dam. These things can save the average family over 30,000 gallons of water every year. And if you're on city water systems, you pay for that water twice. Once when you use it, and again when it goes down the drain. So as you can see, a little conservation can save you a lot of money on your water bill. Just because we live on solar power doesn't mean that we can't have a home office like anyone else. This is ours, and as you can see, we have a computer, fax machine, an inkjet printer, and anything else we need to communicate with you. Of course, all of our equipment runs on solar power.
This is a 12-volt DC fan. It uses only 15 watts, as compared to 50 for a standard model. Now this would be okay over the bed, but it wouldn't be adequate for the areas out in the house with the high ceilings. This store-bought fan uses 65 watts at low speed. I made this one with a DC motor. It uses only 10 watts, puts out about the same amount of air. When buying, remember to be selective. You want a good job for the least amount of watts. So read the labels. We do have a small air conditioner that we can use in this room when it gets really hot. Now let's go see where all this power comes from. This is what we call a control room, and here's what happens. The array up on the roof produces direct current that runs through wires down to this box in the upper left. I have the cover off so you can see inside. This is a charge controller, and it keeps the batteries properly charged. You need to store power produced during the day in a battery bank so you can use it at night. It's just outside this wall, and I'll show it to you later. You only need a few gauges. These are over 15 years old and work fine. All the new ones today, however, are digital. The one on the left shows charging amps from the array. It varies depending on the intensity of the sun and the battery state of charge. We still get power even on cloudy days. The center gauge shows the battery state of charge. The one on the right shows array divert amps. When the controller shuts off power going to the battery bank, it sends the excess to the big red switch. It allows me to direct the power where I want it, like a fan in the attic or down to a water pump. Our main electrical system is 12 volts DC. We draw power from the battery bank and use it to run loads like fans, lights, the refrigerator, water pump, TV, and stereo. The 12 volt power first goes through this breaker box here on the left to supply those loads. The gauge on top of it shows how much is being used at the 12 volt system. In 12 volt systems, you need much larger wire than you have in your house. The lower the voltage, the larger the wire must be. There are advantages to having both a 12 volt and a 110 system. But if you convert an existing home to solar, you would probably use only a 110 system. For our 110 loads, we pull power from the battery bank into this unit. This is a state-of-the-art DC to AC inverter made by Trace Engineering. It's a model SW2512. It produces 2,500 continuous watts of pure sine wave power and supplies the breaker box just above it to the right. It has a 3-stage battery charger, input terminals for grid and generator, automatic switching from battery to grid power. It's utility interactive, meaning you can sell power back to the grid. It has meters for AC and DC volts and AC amps. And it's 92% efficient. The search mode uses only 1 watt. This trace will do anything you need an inverter to do and more. Now let's look at that battery bank. This is the heart of our system. I have 8 Exide 6-volt DC golf cart batteries connected together in series, parallel, and cross-wired. These are acting like one big 12-volt battery with 1,040 amp hours of storage. We have enough power here to get us through 3 days of little or no sun and still have enough to run the essential things in the house. In a standalone system like ours, these Exide GC5s are the most efficient and economical. These are about 6 years old and still going strong. Regular 12-volt auto batteries will not do this job. I check these once a month and add distilled water if needed. That's pretty much it, but I really want to recap all this information for you.
Now that you've seen our solar home, we hope you understand you don't have to make any major lifestyle changes. Living on solar, we do watch the weather reports very carefully. We would only do laundry on a sunny day so that our solar dryer could do its job and we would have plenty of times for our batteries to recharge. Now we'd like to take just a little time to review some of the things we've already talked about.
Consider all your site-specific conditions. Take advantage of all your site has to offer, like trees, prevailing breezes, and exposure to the sun. House design. If you're building, incorporate as many energy-saving features as possible that fit your climate. Here in Florida, we need high ceilings, lots of windows, long overhangs, continuous soffit vents, ridge vents, and radiant barriers. Eliminate your phantom loads. Plug your TV, VCR, satellite, stereo, and other items that have a remote control into a power strip with an on-off switch so that they are truly off when not in use. Remember, phantom loads consume power 24 hours a day, 7 days a week. These little things add up.
Use compact fluorescent lights. They use 1/4 the energy, produce almost no heat, and save you money. Remember to turn it off. Don't waste water and electric. Again, a little conservation saves you money. Choose your appliances for efficiency. Read the labels. Choose the product that does the best job for the least amount of energy.
Use natural gas or propane. Electricity is the least efficient way to heat anything. Gas will do the same job for about 1/3 the cost. Solar is easy. Photovoltaic systems are not complicated. If you can follow a wiring diagram, you can do it yourself. Solar can do anything conventional electric can do. A solar system can run anything from a small pump in a remote area to an entire house with both 120 and 220 volts.
Solar is good for the environment. Power plants are big polluters and very inefficient. Solar power means no pollution. And the best part is, we have never had a power failure and no monthly power bill.
Remember, we are here to help you through every part of going solar. First, we will help you establish your true electrical needs. And then we can design a system that is right for you, with a detailed wiring diagram that you can take to your local building inspector to get permit approval. And since most certified electricians don't have a clue when it comes to PV, I'll be available to answer any of their questions. We also include a list of suppliers for your consideration. However, if you order from us, we can guarantee much better prices. Please don't hesitate to contact us if you have any questions. We hope you've enjoyed your tour of our solar home and that you learned ways to conserve money on your own utility bill. We thank you, and the environment thanks you.